Students, welcome to the lecture 5 of CSE230 Discrete Mathematics. This is Mirza Tanjim, Shorif, Muggdho, and today we'll be studying Introduction to Probability. So you must be wondering why there is a photo of cards here. Because there is a connection between probability theory and gambling. Interesting, right? The fact is, the subject of probability can be traced back to 17th century when it arose out of the study of gambling games. And then, as we see, the range of application extends beyond the games into business decisions, law, insurance, medical tests, and social sciences. Even the stock market, which is the largest casino in the world, cannot do without it. Also, the call centers, telephone network, and the airline companies with their randomly fluctuating load couldn't have been designed economically without this probability theory. So it's very useful and important to study. So in order to address these applications, we want to develop a language to discuss them, and that's why we are going to start with a few terms that are frequently used during the probability theory study. So let's begin. So we're going to start with experiment. What is an experiment? An experiment in mathematics is a procedure that can be repeated infinitely and has a well-defined set of outcomes. So it's a procedure that can be infinitely repeated and has a well-defined set of possible outcomes. Okay, so outcomes here means results. All right, so yeah, and here the set of all possible outcomes of an experiment is known as sample space. I'm sure you've heard of this term, sample space. And the sample space is denoted by omega, capital Omega. Alright, so the sample space is a set that comprises of all the possible outcomes of an experiment, and it's denoted by capital Omega. Let's see some example. So example 1. Look at the figure at the right side. Tossing a coin. Okay, why tossing a coin is an experiment? Because you can toss a coin as many times as you want, and the set of the results is fixed, right? You already know that either a head will come or a tail will come, so the set of the results are well defined. That is why we are calling tossing a coin an experiment. So here, let's say omega 1 is the sample space of our experiment 1. Experiment 1. So it will have two elements in it. If we denote heads by H and tail by T, then there will be two elements in the sample space of experiment 1. So the cardinality of omega 1 equals to 2. Cardinality of omega 1 means the total number of outcomes of this experiment is 2. Let's see another example. Example 2. Rolling a die. I'm pretty sure that you are familiar with this rolling a die. You have played Ludo in your life many times, I guess. So rolling a die, yeah. So you can infinitely roll a die, and here the set of the results is also well defined. How so? We can call the sample space of this experiment 2, which is rolling a die, by omega 2, yeah, sample space of experiment 2. All right, so how many elements are going to be in this set? Tell me. There will be 6 elements because a die has 6 sides of its own, and there are 6 numbers written on each face, right? So any of these number can be coming as a result, and nothing out of this set can be a result of rolling a die. So yeah, that's why rolling a die is an experiment. So my question to you now is sorry, sorry. Hmm. Rolling 2 dice together, it's our experiment 3. Okay, so my question is, how many elements are there in the sample space of experiment 3? If we denote the sample space of experiment 3 by omega 3, so sample space of experiment 3, then how many elements are going to be in it? So I want you to tell me the cardinality of omega 3 and what will be the answers, what will be the elements in the set. Okay, so we have learned what is an experiment and what is a sample space. Now if you want to answer the question yourself, then pause the video and try it for a moment. We're going to see how many elements are going to be in the sample space of experiment 3. Since we are rolling 2 dice together, so every outcome will consist of 2 elements here. One will come from die 1 and the other will come from die 2. Okay, so the outcomes will look more like ordered pairs. Suppose 1 3 is an ordered pair, so it will mean that die 1 showed 1 and die 2 showed 3. Okay, so what we have to determine is how many ordered pairs are going to be in the sample space of experiment 3. Okay, so here's the tricky part. Suppose die 1 had only one number written on each of its face. Okay, suppose die 1 looks like this, so each of the faces have only one in it. Alright, and die 2 is a regular die. So how many ordered pairs would be there then? 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. So if die 1 had only one number written on its face, then we would have 6 different ordered pairs or 6 different outcomes from rolling 2 dice together. Okay, but we actually have 6 different number on different sides of die 1. Okay, so now we are going to use unitary method, that is ঐকিক নিয়ম in Bangla. So for only one result from die 1, we would get 6 different ordered pairs, right? Now since there are 6 different results from die 1 possible, so there would be 6 times 6 equals to 36 ordered pairs as a result. Alright, do you understand it? It's simple unitary method. 1 leaves 6, so 6 leaves 6 times 6. Okay, so yeah, there would be 36 ordered pairs in the sample space of omega 3, and it will look like this. Let's say omega 3, it starts with 1 1, 1 2 up to 1 6. Don't forget to separate the ordered pairs by comma. 2 1, 2 2 6 up to 6 1 6 6. So the cardinality of this sample space is 36. That means the total number of outcomes possible from this experiment 3 is 36. Anyway, so we have learned experiment and we have learned what is the sample space of an experiment, but we are not only interested in determining the total number of outcomes of an experiment, but also interested in some events of our interest. because it's the goal of studying probability theory is to compute the probability of various events of our interest. Okay, so we have to know what is event in probability theory. So we are going to define events and see some examples. Okay, let's go to the next page. Yeah, so events. The formal definition of events is: an event is a subset of a sample space of an experiment. An event is a subset of the sample space of an experiment. So here we have to remember that event is a subset, and whenever we are referring to the term event, we are actually referring to a specific set of outcomes, right? So event is actually the statement about the outcomes, a few outcomes from the sample space of an experiment. So that is why I have clarified it here, that event is a set of one or more outcomes of an experiment. All right, so if you were not clear enough by the definition, let's see examples. We are going to state a problem regarding probability, and we're going to find the event of our interest here. So example, let's roll 2 dice again. Find the probability that the sum of two numbers appeared will be 8. So you have to roll 2 dice, so you will get two numbers from 2 dice. So what is the probability that the sum of those two numbers is 8? So that is the question. So here the experiment, we are not going to solve this problem completely, since we are not still introduced to probability formally. So we are just going to define the event of our interest and try to understand what events are. So here the experiment is rolling 2 dice, you already know that. So the sample space for this experiment, you've already seen this in your previous problem, that the sample space, let's say it's omega, will be a set comprising of all the outcomes possible from rolling these 2 dice. So this set will have 36 ordered pairs here, 36 different results. So yeah, 6 6. Now what are we interested in? We are interested in those ordered pairs whose elements have a sum of 8. Okay, so the event, let's say our event is S, and the event is getting two numbers with sum 8. Okay, so that is event. In Bangla it's ghotona. So yeah, since by definition event is a set and it's a subset of sample space, so it is supposed to have some elements in it, right? And here in this case the elements will be in form of ordered pairs again, and we need to determine what are those ordered pairs where both of the elements sum is 8. So if we start writing, can we start with 1? Suppose I've written here 1, so its pair should be 7, but 7 is not possible to come from any dice, right? That is why we are not supposed to start with 1. We will start with 2 because its pair is 6, so that the sum is 8. So 2 6 is the first element, and then 3 5, then 4 4, then 5 3, and 6 2. That's it. These are the 5 elements or ordered pairs that satisfy the condition of the question. So this is the event, and the cardinality of this set S will be 5. So The cardinality is very important to determine the probability. We will know that later. Let's see another example on the same statement. Okay, suppose you are rolling 2 dice again, and now you are asked to find the probability of rolling a double 6. All right, so you are asked to find the probability that you have 2 6 from 2 dice at the same time. Okay, so now the event of our interest is changed. So suppose the event is D. Okay, you can call it whatever you want. So suppose the event is D, and it's the event of rolling a double 6. Now since it's an event, so it will have elements in it, and it's a set. So how many elements are going to be in this set? Tell me. Only one element will be in it, in form of ordered pair, of course, and the element is 6 6, because this is the only element we are interested in, the only outcome that is asked in this question. So yeah, the cardinality of this set D, or this event D, is 1. All right, so I hope you understand what events are.